Welcome back to The Explainer. Today, we're diving into a genuinely fascinating piece of tech history, and honestly, a pretty great bit of mathematical irony. We're going to look at how three incredibly granular, in-the-weeds mathematical details didn't just support a project, they actually became the ultimate high-level deliverable for AI hardware. It's the story of how fixing the absolute deepest math was literally the only way to solve a massive real-world computing bottleneck. So, picture this. It's June 2020. An advisor named Nolan Buys sends a very specific email to a researcher about a MyTax business proposal. He says, "You may want to try and focus more on the high-level deliverables and less on the details." And it's that classic clash, right? The business side wants the shiny, market-ready product, while the engineer is just totally buried in the intricate math. It's so easy to be told you're stuck in the weeds when you're actually trying to build something revolutionary.
But the researcher totally accepted the challenge. As we're going to unpack today, they proved that fixing those deep mathematical details was the absolute only path to creating the actual deliverable they wanted, a low-power, zero-drift computational engine for a specialized database called SeedTreeDB. You couldn't just build this engine on top of old math. You had to invent new math to make the whole shebang work.
Okay, so here's our roadmap for today. We'll start with the deliverables dilemma, then hit our three mathematical pillars, side normalization, the cardinal horizon, and the silver partition, and finally, see how it all comes together in the zero-drift engine.
Let's jump right into part one, the deliverables dilemma, and what it means to crash into the trig wall.
So, to understand this trig wall, you have to look at how legacy AI systems operate. They rely on what are called continuous polar manifolds. In plain English, when they calculate attention scores, they use heavy trigonometry, sines, cosines, all that stuff. And this forces the hardware to constantly guess or approximate, which turns precise coordinates into this irrational, energy-heavy, continuous, well, gunk. The Hayate Universale or HU framework goes for the exact opposite. The goal is a discrete, low-power, bit-perfect system that completely bypasses trig.
And if you want to know why this matters, just look at a 28-nanometer CMOS hardware benchmark. If you take a standard floating-point 16 multiplication, which costs about 3.7 picojoules of energy, and replace it with a discrete reciprocal shift, the energy cost absolutely plummets to 0.05 picojoules. I mean, that is a staggering difference. It drops the absolute metabolic energy floor of the hardware, which proves that yes, getting the math right saves massive amounts of actual, physical battery and processing power.
Moving right along to part two, pillar one, side normalization.
To actually deliver that high-level product, we have to start at the absolute foundation. Side A normalization is this first principles algebraic framework. Instead of the old method of radial normalization, which assumes a curved radius of 1 and just drags us right back into heavy trig, this framework anchors everything to a straight line, specifically the transverse constant where side A equals 1. It takes a messy, continuous curve and transforms it into a clean, discrete, rational grid.
In practice, this creates what's called the Cayley-Theory bridge. So instead of your coordinate system acting like this smooth, slippery ramp where data just endlessly drifts away, fixing A to 1 creates an ASCII staircase. Rotation turns into bit-perfect physical clicks between states. You're no longer just estimating a location, you are clicking firmly and definitively into a known slot.
Okay, that brings us to section 3, pillar 2, cardinal horizon.
So, with the algebra fixed, we need the next detail for our deliverable, the symmetric diamond tile spiral. This concept completely replaces the abstract zero-dimensional Cartesian ghost points of legacy math with actual, physical, discrete tiles. In this geometry, these triangular tiles are the primary primitives of information. There is no more infinite, fuzzy space between points, just strictly defined, countable surface regions.
And what's really wild is how this geometry perfectly organizes itself. The spiral address, which is called Z, propagates outward from a fixed central quark, completely killing the old idea of an infinitely small origin point. Because of its parity-driven rotation, the system forces a beautifully symmetric distribution. The white tiles on the west and east axes perfectly catch the squares of integers, Z squared. That right there gives us undeniable, hard geometric proof of binary power law expansion, totally free of mathematical drift.
All right, almost there. Section 4, Pillar 3, Silver Partition. Our final mathematical detail is the Turing cell mereology. Now, mereology is really just a fancy way of studying how parts relate to a whole.
What this proves is that a unit constant can smoothly divide into its own substates without any spatial approximation error. You don't lose data or energy to the void. The space partitions perfectly into itself.
This whole thing is governed by a super precise halving equation, d0 equals 2d1 plus d2. Mathematically, it just means the computational cell is perfectly resolved by 2 primary sublenses and 1 secondary refinement. And why does this matter? Well, because it creates a deterministic, hard halting point. The computer knows exactly where to stop calculating. No guesswork.
See, legacy point set systems completely lack a cell wall. Because they rely on infinitely small points, computation can technically divide forever, which leads to a massive drain of resources known as xenodrift. The HU silver cell completely solves this by providing a physical boundary. It's actually a lot like how the silver ratio stabilizes the architecture of a Japanese pagoda against earthquakes. This cell wall stops that infinite division dead in its tracks and secures the state perfectly.
And finally, Section 5, the Zero Drift Engine. When these 3 mathematical pillars assemble, they create the exact high-level deliverable Nolan Beast was asking for in that email. First, it shifts coordinates without heavy trigonometry using side and normalization. Second, it maps those addresses cleanly onto the discrete diamond tile spiral. And third, it halts deterministically at the silver cell boundary, stopping context decay and energy drift before they can even start.
The result of combining these 3 foundational details? The system completely shatters the trig wall. This zero-drift engine achieves a jaw-dropping 74 times reduction in energy per scoring operation. Guys, this isn't just an incremental update. This is the fundamental hardware-level key required to unlock infinite context capabilities for large language models. A total game changer. Which brings us to a final, somewhat provocative thought. When do the most complex, granular details actually become the ultimate deliverable? Well, to answer that 2020 email, when you are trying to eliminate the massive, foundational computational drift of legacy AI, you can't just slap a new user interface on old math. The foundational mathematical details don't just support the deliverable, they literally are the deliverable. If you don't fix the math, you flat out don't have a product. It's a pretty brilliant reminder that sometimes, to build the highest level technology, you have to be willing to get deeper into the weeds than anyone else.